A baghouse filter is an air pollution control device and dust collector that removes particulates or gas released from commercial processes out of the air. Choosing the correct baghouse filter will maximize performance, increase filter life, reduce system downtime time, and save you money. With so many different type of baghouse filter fabrics and treatments options to choose from, it is important to know which is the best fit for your specific application. As a part of the process, it is split in filtering period and shaking period. During the filtering period, the milk powder is fed into a cloth by applying suction on the opposite side of the feed entry to make easier the separation. During the shaking period, the bags are shaken by applying pressure so that the adhered powder falls and is collected from the conical base. Using Baghouse filter can help you improve performance in one of the four following ways: reducing operation pressure, increasing airflow, increasing filter bag life, and decreasing the number of installed filter bags. Less energy means saving money. In order to design the baghouse filter, we have to pick between woven or felt fabrics. By checking the properties of the materials used in a bag filter depending on the material, temperature, and resistance. Components of baghouse dust collector. Depending on the cloth area, we can determine how many components are needed in our baghouse filter design. The capacity of a compartment is determined depending on the area of the cloth needed for the filtration. Pulse jet filters use a short compressed air stream along the length of the filter bags to dislodge the contaminants and drop them into the hopper. Also, cleaning of filters is possible in the pulse jet baghouses because compressed air pulses are pretty short. With this guide, we can calculate the number of compartments. Filtration speed. Efficient filtration requires that the filtration rate be in the range of 0.005 to 0.050 meters per second. Once we choose the fabric, we can use the following table in order to reference the initial filtration speed by identifying the type of particles to be removed, the filtration rate for the woven fabrics, and the speed filter for felt fabrics. The filtration area, the amount of cloth, should be increased to allow one or more compartments to be taken out of service for cleaning or maintenance. So we have to take the fabric area and multiply it for the number referenced in the table. For example, if you need a fabric area of 2,300 square meters, you have to multiply it for 1.17. Calculation of the efficiency of collection. The collection efficiency in the filters bag are usually between 98 and 99%. With the following equation, the total efficiency is calculated in function of operating time between cycles cleaning. We can determine the efficiency decrease with increasing filtration speed, and that increase with the accumulation of particles on the fabric. The penetration due to pores of the layer of particles is a function of filtration speed and is given by following this equation. So, B and C are empirical constants. The penetration due to particle morphology is a function of particle concentration and it is given by the following equation, in which P is particle concentration and C is an empirical constant. The non-true density of the particles is the mass of the particles per unit area of the fabric. Then we can use the following equation. Then P delta is a pressure drop across the fabric, K is the tissue resistance factor, and V is a filtration speed. The pressure drop offered by the filter cloth is proportional to the filtration rate. The pressure drop can occur in the layer of a particle that have accumulated on the cloth is calculated by the following equation.